All right, so let's take a look at these two by two matrices. So clearly if you're dealing with square matrices, and when we say a square matrix, we're talking about a matrix that has the same number of rows as it does columns. Okay, so whether it's a 2 by 2, 3 by 3, 4 by 4, those are square matrices. So I want us to look at the difference between having the product AB and BA. Now we just did that with some larger matrices, but I want to make sure that we see that here as well, to know that even though the result would have the same dimensions, they'd both be 2 by 2 matrices, the result is not the same though. All right, so let's do this just like we did before. Start with this row, rotate that so that it kind of aids us with the multiplication. We see that a little bit better. So 2 times 1, so 2 minus 24. And then 2 times negative 3, we get negative 6, and then plus 27. And then I'm going to go to my next row, 1 and negative 7. Put my 1, negative 7, let's multiply these. So that's 1 plus 56, then negative 3 minus 63. So combining these, we get negative 22, positive 21, positive 57, and negative 66. All right, done. But let's flip things around and do B times A. All right. So with this one, we're going to start with B as the guy who's using the rows. We're going to rotate that and do 1 and negative 3. All right, so 1 times 2 is 2, then we have minus 3. 1 times 3 is 3, and then we have plus 21. All right, and now we're going to work on the negative 8 and 9. So negative 8 and 9. So negative 8 times 2 is negative 16. We get plus 9. Then we have negative 24 minus 63 when I go to the next column. All right, so we combine these guys. We have negative 1, 24, negative 7, and negative 87. So we can clearly see that matrix multiplication is not commutative. Even if we have square matrices, right? The dimensions were the same. They're still 2 by 2 at the end, but the result is wildly different. So always make sure you pay attention to how you set things up. All right, some things to note is that there is an associative property of matrix multiplication, which says if you have 3 matrices that you're multiplying, of course you can't rearrange the order, but you can rearrange like what you multiply first. So you can multiply B and C first, and then times A, or you could do the first 2 and then multiply times the third one. And then we have this distributive property. So if we have matrix A times the sum of these guys right here, you can do A times the first one, A times the second one, and then add the results. Now, one of the things to keep in mind with all of this is that in order to add, remember, you have to have the same dimensions, right? So all of these properties here are based on, that you can do the multiplication or you can do the addition. Because if you can't, well, then the properties don't really apply and you wouldn't be able to do anything. All right, coming up, we're going to be talking about the identity matrix and all kinds of fun shenanigans we're going to have with that.